All right, so on example one, we're going to go through kind of the most basic version of using the Pythagorean theorem, using that equation. So solving for the missing side of a triangle. We're going to start out by solving for the longest side. So we're solving for the hypotenuse here. When we say a squared plus b squared equals c squared, what we are referring to for a and b are the two smaller sides of the triangles. Specifically, you could say the two sides that are touching the right angle. So a and b in this case would be 7 and 17. Now, you don't need to pick a certain one. So like this one doesn't have to be a or b specifically. It's just that these two are not going to be c. Whichever one you want to call a and b doesn't really matter. But this side is our c side. That is, c is always the hypotenuse. So in this case, if we're going to say a squared plus b squared equals c squared, what we're really saying is that 7 squared and 17 squared add up to whatever x squared is. Okay, so we can go through. We can say that we have 49, and think about what 17 squared should be. 289. Okay, you can do that on a calculator. So then together we get 338. Okay, at this stage, in order to get rid of the squared symbol, so keeping in mind what this means, x squared means x times x. So we're looking for a number that when you multiply it by itself, we get 338. Okay, so like, let's do a slightly, easier scenario before we do that. What if we had 25 equals x squared? Well, the number that when you multiply it by itself, x times itself, that number would be 5, right? 5 times 5 is 25. So that means that 5 is the x value in this equation. Well, how do we get there algebraically? What do we show when we're showing our work? We do this. We do the square root symbol on both sides. So on the left side, we put the square root of 25. Well, that is 5. It's the number that when you multiply by itself gives you 25. That's what it means to be a square root. On the right side, when we have these two symbols together, the squared sign and the squared root, they're opposite operations, just like addition and subtraction are opposite, multiplication and division are opposite, squaring and square rooting are opposite. So they cancel out, and we just get the x. So that's how you would show your last step. Okay, so up here, we're going to say we'll square root both sides, and the end result is that we get the square root of 338 equals x. Now, if I was going to draw out what is meant by the square root of 338, first, let's draw what's meant by the square root of 25. Okay, 25, if it was an area, is what you get when you multiply 5 by 5. But I could also rewrite that as the square root of 25 times the square root of 25. Square root of 25 and 5 are the same thing, right? These two things are the same, just written in different ways. So if I write it in this way, square root of 25 times square root of 25, what that means is that when you multiply this thing by itself, the square root symbol goes away and you're just left with the 25. So for our example, we have the square root of 338. So what the square root of 338 is, it's the length of the side of a square that has the area 338. Now, I'm not sure off the top of my head what that's going to be. I'm fine with going to a calculator at this point. We don't do a lot of square roots by hand anymore. We've got calculators that kind of make that process a little simpler. Okay, so it's 18.38. So what we are saying is that the square root of 338 is the number 18.38, and then it kind of goes on with some other decimal points. So if I multiply 18.38 times itself, so 18.38 times 18.38, I get 338. So this is the length of the side of a square that has an area of 338. In two different ways. I can write it as 18.38, or I can just use this symbol, square root of 338. Now we tend to want to just use the symbol because when we use the symbol, this is exactly right. Whereas if I don't keep writing out all the decimals up here, then this number is just close to right. If I actually just did this number, 18.38, and I squared it, 18.38 times 18.38, I'm not going to get 338. I'm going to get really, really close, 337.82, but I'm not actually going to get this. So this is not actually the square root. It's just really close. This is actually the square root. So if I say SQRT, square root of 338 times SQRT, square root of 338, I'm just going to get 38. Okay, so we tend to want to use this symbol more than we want to use like decimal values. And that is what is being shown in the problem over here. Square root of 338 is the answer they get for x after they go through the Pythagorean theorem. So we put in our shorter sides, we put in our 7 and our 17, we square them, we multiply them by themselves to get 49 and whatever the other number was. What was it? 289. We add those two up to get 338. That is x squared. So that's the area. If I was to take this x here and do another x down and find the area of that square, the area of that square is 338. The length of the side of that square is the square root of 338. Okay, the final thing they do is they simplify this in a certain way. So they say that square root of 338 is actually equal to 13 square root of 2. Now, the way they get that is they break up this number. So what they do is they say 338 is divisible by, well, it's a even number, so it's divisible by 2, first of all. So we could say, okay, what do we get if we divide it by 2? That would be like 151, maybe 169 times 2. I believe that would be what we would get if we divided this by 2. Now, if you know your perfect squares, your perfect squares are like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36. These are all my perfect squares. If I keep going, so 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, and finally 13 squared is 169. Okay, so when we're simplifying square roots, we're looking to try to factor what's under the square root as much as possible, and ideally we're looking to get a perfect square number in there. Okay, if we do, this is what we're allowed to do. We're allowed to say that we can break this up and say that we have the square root of 169 times the square root of 2, and we know that the square root of 169 is 13. 13 times 13 is 169. So we get 13 square roots of 2. Now that's the final, simplest way that we can write it at the end. If you want to see, why can we break that up, one simple way of doing it is this. If we say that we've got some value in here. So for example, like let's do, what do you want to do? Let's do 3. No, I don't want to do that. I'm trying to remember. There's a good one that we can use. 36 is 9 and 4. Okay, so square root of 36. This will be a good example that shows that this process works. So 36 we could break up into 9 and 4, right? We know the square root of 36 is 6. And we know that the square root of 9 and the square root of 4 are also going to be whole numbers. Square root of 9 is 3. Square root of 4 is 2. Okay, so we've shown here that we are able to do this process. We're able to break apart things on the inside and then separate them into separate square roots. And that's a procedure that you're going to go through when you're working with square roots quite a lot as your last step, your simplifying step. So it's a good one to feel comfortable with. Okay, so we can move on now to our next example.